Hi folks, so in this video I'll talk about control flow and some common programming language constructs that are related to control flow or allow to determine or to define or to modify the control flow. Starting with the definition of control flow. Control flow is the order of the execution of individual instructions of your program. And the instructions here can be the statements, function calls, and in general, if we talk on higher level as for instance about algorithms, not programs, control flow would be basically the order of steps or the order of the algorithm instructions. So there are some constructs and concepts in all imperative programming languages that allow to impact the control flow or modify it. So the reason I'm saying in imperative languages, because in non-imperative or in declarative languages, the notion of control flow is doesn't really exist, because if you remember, we talked about this in declarative languages. The written program really defines what needs to be done and not how, and control flow is all about how it needs to be done, because we say execute this instruction first, then this, and in declarative we don't care. The programming language implementation will take care of the order of statements that it will execute to get the results that we want, and the author, we as the authors of the program, we care only about the results, and that's what the declarative language gives us. So so everything we'll talk about in this video is about imperative languages. So there are some very primitive concepts and or language constructs that help to define the control flow, and the most primitive one is actually the sequence. So it's a basic notion of when you put instructions or statements one after each, one after the other, then there is some implicit expectation that these instructions will be executed in the same order. So this is mostly true, except for some cases where other control flow statements or other concepts of the language interfere with the control flow. So we'll talk about most of them. So another primitive is the label. So some languages have give you this ability to define labels, and basically before writing the statement, you would add some label in front of it. It can be a numeric, it can be like a line number implicitly without you adding it yourself. It can be some string, text value, whatever you put there. So that becomes a label. There is some special syntax. For instance, it can be your label and then colon. And then all the languages that provide this, that support this label notion, they also have this go-to keyword. And go-to is a statement which says, basically change the control flow and move the execution back to the line determined or defined by that label. So for instance, if we say, if we want to add 1 to a given number 100 times, we can say we can prefix some line where we say sum plus 1, right? Sum equals sum plus 1. And then we give that line a label, line 0. And then in the next line we can say go to line 0, which means it will add one to some, and then in the next line it will see it's a go to statement, and it will go back to the same line. So it will keep adding one infinitely. So this is obviously not a good thing to do, but just an example how this works. So basically, go to jumps, the execution will go to the line with that given label. And another primitive construct that most of the languages, imperative languages, support are the function calls. So in different languages, these are called differently. It can be function, method, procedure, routines, coroutines, and different names, but basically the meaning is almost the same. So you have a code, named piece of code, and it's called a function that does one thing for you. So we wrap it as a function because either we need to call it multiple times, or we want to separate the logic and give a name, like a descriptive name, to know what we do, make the code shorter, so for different reasons. But basically, when you make a function call, the execution, the control flow will start executing whatever code is in that function. So when we define when we get to the functions, when we learn about them, we'll see how it works. But basically, you change the order of execution or the control flow by calling a function, because if otherwise it would just continue with the same sequence. So these are the basic primitive constructs. And then we have the control flow statements, which are again most or all, I think all imperative languages have some types of control flow statements. And these are basically the statements that allow the program to choose which path to follow. If there are like more than one paths in the code to go forward with, so control flow statements will help with picking one of them. So if you remember from the previous example problems that we discussed, for instance, if we wanted to see if this is this juice is orange juice or not, right? So if it's an orange juice, we wanted to add one to our current number or current count. If it's not an orange juice, we wanted to just go to the next box. So this is two different code paths, and control flow statement would help us to pick which one we want. So there are different categories, and before that I mentioned code path. So the definition of the code path is basically if you have different paths in your code that the control flow can go through, each one is a separate code path. So we'll see. I'll bring this up explicitly when we go through an example again. So different categories of control flow statements include choice statements, which are basically conditional statements. They allow you to pick one of the paths, two or more, based on some condition check. So you say, in our example, it would be if juice.flavor equals orange, that would be our condition. Then do something. So that would be a choice control statement. So we won't cover all of the statements now. I think I'll do a separate video for each of the category. So in this one, we'll just introduce what types there are, what categories, and other common notions, and we'll do a deep dive in the next couple videos. So choice, the two main types is this if condition, which has different syntax in different languages, but the meaning is the same. So we check if condition applies, then do something. In some cases, we can do, if it doesn't apply, we can do something else. So that's what if does. And then there is another statement which is also common, but not all languages have this. It's called a switch or case, where we have multiple paths. Instead of just two, we can provide multiple paths forward. So we can say switch some variable, and if that variable can have multiple values, we can have a path forward for each of the different values or whatever set of values we want to define. So let's say we have a person and we want to identify which group, and we are splitting people into groups by age. So we want to identify which group this person should be in, and we can write a switch statement saying switch age and check if it's between, let's say, 14 to 20, put group in group A. If it's 21 to 30, put in group B. If it's greater than 30, put in group C. And then if none of this, then we say, okay, you are too young for now. So this is an example of how we would use a switch statement. In some languages it's called case. I don't know, maybe some others have a different name, but the most common ones are switch and case. So those two are the choice control flow statements. The next and the bigger category is the loops. Loops or iterations. So loops are basically the statements that allow to run the same instruction or the same set of instructions multiple times. And again, loops come with some sort of condition. There are different types actually. You can specify a condition, so we can have while this condition applies, repeat this, or we can have based on a count saying do the same thing n times. And there is also another type of loops which is based on the collections. So we don't know about collections yet, but if your object type is collection, you can do this same instructions for each item in this collection. So these are three different types, the common ones, and we'll get to loops in a separate video. And then the next statement, the next category of statements is the termination or exit or unconditional halt. So it's basically a single keyword which terminates the program. So there is no condition check, nothing. If the program hits this keyword or statement, then nothing else will be executed. The program will terminate. So these are the main and most common categories that all imperative languages have. So there are some more advanced concepts in most of the programming languages, and they are not common to all, but so some we won't get into this yet. I think these are more advanced and maybe not for this course, but maybe in some of the later videos I'll cover some details. So just to give a high level overview of what they are and what they do is one group is the events or signal interrupts. So it's basically there are some specific types of signals that the operating system or mostly operating system can send to the process or your running program, and then you can have this statement in your program saying, if I get this signal, if the program gets this signal, do something, right? So these are different from the if else statements, so just choice statements, because the choice statements happen as a regular instruction in your program. So when you get to the choice, it looks for it, checks the condition and knows what to do. But these signal interrupts are basically, you write it once in your program, and no matter where your program control flow is, which instruction you reached, if that condition happens or if that signal is received by your program, that block will be executed. So the context of your control flow switches completely. So this is one group of these advanced categories. Another one is the exception handling, which most of these object-oriented languages provide, and this is a similar thing, but basically you can define, it's not predefined set of signals from system, but you can define your own types of exceptions. And exception is basically when something is happening which is not expected, so it's an edge case or something that shouldn't happen. So if you can say, if this case happens, this is an exception, and then you define a piece of code or your piece of your program that will handle this case. And again, it can be completely in a different location, unrelated to where your currently executed statements are. So it comes with the context switch again. So this is another group, and the last one I wanted to talk about is the continuation. So some programs, some languages provide special constructs for switching context between these different pieces of code, which are running based on some conditions, or they can run in different threads. We don't know about threads, but imagine some things can run in parallel, or they don't run in parallel, but the code can, like the piece of code can start executing, and then because of something is missing or something needs time to run and complete, this code can yield its control flow, and the control flow will be returned to some other part of your program. It will continue executing until this previous piece of code completes what it needed to complete, or gets the resource it was waiting for, and then the control flow can come back to this piece of code, and this will execute until completion, then return back to that. So this, like, the common term is continuation, but there are some unrelated constructs that are used in different languages. So again, this is a more advanced topic. We'll probably not talk about this again. So the main thing from this video is basically we know that there is a control flow. It's the order in which the statements or instructions are executed, and there are some statements which we can use to control it. And in the next several videos we'll cover the choice statements, the loops, and unconditional exit termination. That's basically just a couple of keywords. There is exit, there is some languages have terminate, so I don't think we need to dedicate a separate video to it. So let's do choice category in the next video, and then the loops in another. All right, thank you. See you in the next one.